So let's go ahead and start. Hopefully you got your notebooks out because I'm going to go over. Now, if you printed out your unit, then you can actually just mark up your unit, okay? If you printed it out, then you could just, write notes in the margin or whatever. But that's up to you. If you have your book, then you can still highlight it, okay? If you want to write in your book. And if you don't have a book, then you can just write notes. What I do is I usually go through and pick out what's important, what's not. Of course, I do know that some people in here invented mathematics, so you already know it all. So that doesn't concern me because I'm not teaching to you. So with that being said, let's go ahead and move down to the first definition. Uppercase statistics. This is the word that starts with a capital S. There is a reason it starts with a capital S. I'm trying to blow it up for the people at home. There we go. Statistics with a capital S is the science of organizing, summarizing, analyzing, and interpreting data. Now you can write that first sentence and then say, instead of draw conclusions, just say interpreting data. The key word is collecting, organizing, summarizing, and interpreting data. That is a test question. It's also a standardized test question. And you will be asked on a standardized test, what is the difference between uppercase statistics and lowercase statistics? We'll get to that in just a minute. I'll go ahead and tell you. Lowercase statistics, variables used for the sample. Variables used in formulas for the sample population. Don't put population, just put sample. Okay. So uppercase statistics is the science of organizing, collecting, summarizing, and interpreting data. Lowercase statistics, starting with a lowercase s, is variables used in the sample. We'll get to that in just a minute. Population is always the bigger group. An example of population would be all students at Tri-County Tech. An example of a sample would be students at Anderson campus. The population is always the bigger of the two. Now, since lowercase statistics is variables used in the sample, what's used in the population? A parameter. Parameters are variables used in the population. Write that down. Parameter is variables used in the population. Now, also go back to lowercase statistics. That variable is going to be a letter in the alphabet, like X bar or S for standard deviation. The variables used in the parameters are parameters used in the population. Does anybody know what they are? Not alphabetic numbers, but Greek letters. So you need to make that distinction, because one of the points in understanding a parameter versus a statistic is in a presentation. If you're being presented this stuff, then you need to know the difference between a Greek letter and a regular alphabetic letter. Okay? The difference is, if it's an A or B or X or S, then that means it is in dealing with the sample. If it is a Greek letter, it's dealing with the population. Lowercase statistic, sample. Parameter, population. SSPP. Everybody got that association? Because you're going to be asked that on the test or a standardized test.
No, can you say?
I'm sorry, say again?
Can you say what you just said again, please?
Parameter is variables used for the population, and there usually are Greek letters.
Okay.
It's going to say it in just a minute. It's going to have it in a box. They just have it in a different order than I presented. Okay,
and you said something about A, B, X, and S.
Okay, if you are presented material like in a presentation, and you have a letter like A, B, C, X, or S, you know, the letters we use in our alphabet.
Yes.
Then that is a statistic, lowercase statistic. If you are presented with Greek letters, and we'll get into those like sigma and mu, then you're talking about the population. And the population is the big group. The sample is a small group of the population that's used, and the goal in probability and statistics is to take the sample and predict for the population. Because of two things that are most important to us in our career: time and what? Money. That's why we use the sample to predict for the population. Okay? And there's where you see lowercase statistic. Now, if you want to write down that definition, knock yourself out, but it is basically a variable used in the sample. In just a minute, you're going to be given parameter, but it's going to be way outside. I don't know why they didn't put it up there at the top with the sample subset and all that. I don't know why they didn't put it there or put it below statistic. But then they go into inferential and descriptive, and then they say parameter. So I don't understand the reasoning there. There it is. A parameter is a numerical summary of a population, a variable used for the population. Okay. Now, those are just some of the little things. Inferential. I don't see descriptive anywhere to y'all. Let me just make sure they didn't cover descriptive on the previous. They did? Okay, I can't hear y'all, so. Okay. Okay. As what? Okay, thank you. Oh, there it is. That's a good place for it. You know, don't hit enter and bring it down one sentence. Keep it in the same sentence. That's a good way. All right. Descriptive statistics is organizing and summarizing data. That would be like you going out counting cars and finding, you know, what car is the most popular, or you taking your grades and averaging up your grades. Everybody got it? In other words, you actually go out and find the numbers and you calculate the numbers. Inferential is when you predict. Okay. Let's say that you're doing, let's say that you're doing a graph of DUIs on Michelin Boulevard in the last 6 years. And you go to the DOT and you pull the DUIs on Michelin Boulevard in the last 6 years. And then you draw a chart, and then you draw a line, and you predict how many it's going to be this year. That's called inferential. Keyword is predict. Inferential predicts. If you do your average, are you predicting what you're going to make in psychology? No. If you're doing the average in math, you're not predicting anything. You're just saying what your numbers add up to. Capiche? That is a standardized test question. They love to ask these definition questions. They love to ask these on standardized tests. So descriptive is summarizing and organizing data. Inferential is, okay, I use the word predict, which is such a difficult word. Extend it to the population. That's predict. Okay, and measure the reliability of the result. Okay, inferential is when you take other data and you predict. All of these are test questions so far. I haven't skipped anything because if I cover it, if it's in a box and I cover it, then chances are it's going to be on the test. If I skip it, then you read it and you keep going. You don't worry about it. Wait a minute, I better go look downstairs to make sure that it put something in the last sentence. No, they didn't. Qualitative and quantitative. Write these down. Qualitative, blondes, brunettes, and what? Redheads. Blue eyes, green eyes, brown eyes. What are qualitative data? Qualitative categories. That's all you need to say, categories. How do you know they're categories? Give me the average of them. Somebody in here, give me the average of blondes, brunettes, and redheads. No, be quiet. You're from Ohio State. You can't add. All right. There. Why did I ask you to give me the average of blondes, brunettes, and redheads? Because you what? You can't. Give me the average of brown eyes, blue eyes, and green eyes. You can't. Because it's non-mathematical. I'll give you even a better one. Give me the averages of zip codes. You can't, because zip codes don't have what? Mathematical meaning. Two more good ones. Area codes. And what does all of us have? Social Security number. Okay? Those are numbers, but do they mean anything? Nothing. They're identifiers, they're categories, they're characteristics. Okay? So make sure you know the difference between qualitative and quantitative. Quantitative, you don't have categories, you have, just like in boxing and martial arts and wrestling, what do you have? Classes. Write that down. In quantitative data, you have classes, which you can find the midpoint, and that is basically the average. I know I'm going kind of fast, but these are definitions, and y'all were supposed to do what? Y'all were supposed to read this. So these questions in the, I hate when stuff sticks on the bottom. These are things, the boxes, the green boxes, that is like, you should already have those highlighted. Okay? That vodka and fluoride just don't go together. That's a joke. That's a joke, okay? Please don't be calling my boss, telling her I'm drinking. I don't drink vodka anyway. I drink bourbon. All right. Discrete and continuous. Kevin already knows that drink. So. All right. So a discrete variable. I like to tell students to put concrete beside it. You know, discrete, concrete. Because concrete don't give. And a discrete variable doesn't give. What do you mean? What the heck are you talking about here? Meaning that it's predictable. It's like a rational number. What's 4 divided by 2? Is it any other number? Could it be a decimal? No, it's 2. 4 divided by 2 is 2. What is 1 divided by 2? 0.5. Is it any other number? No, it's a rational number. Rational, concrete, predictable, discrete. Versus irrational. If somebody's got a calculator handy, type in the square root of 7, or the square root of 2, or pi. Somebody tell me the last digit of pi. Can't what? You can't do it. Okay? That's like telling me what number is infinity. Irrational. Irrational, square root of 2. Pi. You can't tie it down. You can't predict that next number. Therefore, it's irrational, which means what? It's continuous. You'd be surprised on how many teachers can lobotomize you on those two definitions. It's that simple. But I'll even give you a more simple definition. Can anybody make more simple? Just one word each. A discrete variable, and this is what you highlight in your definition. A discrete variable is a variable that starts with a C. Well, that's a good word. You do control it, but count. Then what else is there besides counting? Starts with an M. A continuous variable, you don't count, you what? Measure. Meters, liters, grams. Meters is what? Distance. Liters is what? Volume. Grams is what? Weight. If I tell you to go outside right now and measure the height of that tree, that first tree right there, y'all would come in with 30 different answers, because 15 of you can't read a ruler, okay? So you would just round it up to 25 feet. And then several of y'all would say, well, it's really 24 3/4 of an inch, okay? And then some of y'all would say it's 24 5/8, and some of you would say it's 24 3/8. In other words, when you measure something, there's going to be different answers. When you count something, how many of you, if I tell you to count the eggs in a carton of eggs, how many of you are going to come out with 12? Exactly. When you count, everybody gets the same thing. When you measure, it doesn't happen that way. And that's the difference. Now that is a standardized test question, just like quantitative and qualitative. And it's going to be on my test at least 3 or 4 times. Hint, hint. Question, gripe, complaint. So far, everything's pretty much standard. Go ahead and write down page 9, bottom of page 9. You don't have to write these down per definition. I'm going to give you the short definition for it. This is for standardized testing. I don't test you on this. Nominal is umbrella. Nominal covers everything. If I tell you to go outside and measure those trees, that's nominal. If I tell you to go outside and count cars, that's nominal. Okay? But what if I tell you to go outside and count cars and put it by color? Then it goes from nominal to what? Ordinal, because what is color? Some type of what? Order. So that's the word you put for ordinal. It's got to be in some kind of order. Another word you can think for nominal, nomenclature. What the heck does that mean? What does nomenclature mean? Meaning you're describing something. Okay? Nomenclature, nominal. Okay? Nominal covers just about everything. Interval. Y'all know when you're a baby, or you know a baby is called what? 3 days old, 6 weeks old. If you're 0 days old, does that mean that you evaporated? I know that's extreme, but you know, if you're 0 days old, are you still there? Yes. You're still there. That's the day you're born. 0 does not mean that you evaporated. That's interval. Okay? And it says, what does it say? 0 does not mean what? The absence of quality. If you're 0 days old, that does not mean that you evaporated. Or that you came, just all of a sudden appeared. Okay? So I would say your birthday is pretty good, you know. I was born December 6, 1966, but that doesn't mean that I was, you know, just all of a sudden appeared. Okay? Ratio, plural ratio. Ratio, temperature. 0 means, dang old, it's freaking cold, okay? There ain't no heat at 0, okay, or absolute 0. Whichever it depends on. Okay? Now, I just give you that, and they give you a little example here on the next page. So you might want to write those down if they're not like mine. Gender is nominal. Temperature is ratio. Number of days in the past week that a student studied is measured as ratio. And letter grade, ordinal, because A's, B's, C's, and D's, that's in some type of order. Okay? Like I say, these are in your book. And that's 1.1. So you've got about 8 or 10 definitions in there that is very important. I'm going to move on to 1.2. Observational versus experiment. Observation. What is an observation? It's when you stare at people. No, I'm just kidding. It's when you actually just what? Observe. A good example would be sleep apnea patients. What do people do if they're going, you know, to see what their problem is sleeping? Well, they video them while they're sleeping. Some of y'all might have seen videos of people sleeping. It's usually the night camera vision, everything's green, and you see a person do the Undertaker. I mean, just sit up all of a sudden and then lay back down. And then you see a person drawing with their hands while they're sleeping. You ever seen any of these videos? Yeah. Okay. Well, I've seen some. I'm weird, I guess. Okay, what if I take one of those people and every time they move, I hit them with about 120 volts of electricity? And that would be an experiment. Why? Because I'm introducing something into the observation. Okay? That's the difference between observation and a what? Experiment. That's what I want you to know the difference between. Now, let's go down here and let's look at what they don't. Two of the most important things in the book, and they don't put it in a box. Right here. Explanatory and response. Explanatory has an X in it. That means it usually means the x-axis, which means that is the independent what? Variable. It's the one that causes everything. The response variable is your y variable or your outcome or your dependent variable. Now that's very important for you to know because you're going to see some homework questions that's going to say explanatory and response variable, and some of y'all are going to be like, what the heck is that? Now you're not, because you understand that the input is the explanatory and the output is response. Think of it like this. You can't study the gas mileage of a car if you ain't got no what? Gas. Gas would be your explanatory response, and your, or whatever, explanatory variable. How much gas you put in the car, and then what's the output? The gas mileage. So your X value would be the gallons of gas. Your Y value would be how much you traveled. Capiche? Of course, that's not important. I don't agree with this book on some things. One thing I don't agree with, taking 2 sections to talk about 4 words. And they did that in 1.3 and 1.4. They could have all put it in, or I'm sorry, 5 words. They could have just put it in 1 section. Oh, here we go. We're getting into it here. No, this isn't it. I don't get into observational and designed. I don't get into that. You can read it for your homework. I'll give you a second to put that in your notes. Go ahead and put it in your notes. I don't test you on it, but you might see something written in your homework about it. An observational study measures the value of response variable. That is observational study. The research observes. That's all you need to know. They observe. Think of sleep apnea. And then, of course, a designed experiment is where something is interjected into the observation. If a researcher assigns the individuals in a study to a certain group, intentionally, see the word intentional? That's the interjection. Intentionally doing something, giving them pills. Giving them a placebo versus the red pill or the blue pill. Okay? Gosh, you wish you'd taken the what? Which pill? Forget it. Y'all never watched The Matrix. It's not a cartoon, so a lot of people don't even watch it. I don't do compounding, but you might want to write it down. I don't test on it. Compounding is when there may be a relation between an explanatory variable and a response variable, maybe due to some other variable. What in the world? It can be a lurking variable also. Okay? Compounding, it means that there's a lurking variable. Let me give you an example. Let's say they did a study of deaths, human deaths in the last year. And they found that drowning deaths increase the same amount as Rocky Mountain spotted fever deaths. Is there a relation? And most people would say no, but there is a relation. Anybody know? There's a lurking variable behind the increase in drowning deaths and the increase in Rocky Mountain spotted fever. Anybody can anybody think of it? Well, when do you go swimming? What season? And when do you go hiking? Summer. Some spring and summer. You can say spring and summer. In other words, the seasons is the lurking variable that confounds the death rate of drowning and Rocky Mountain spotted fever. Because the more you're outside, the more you're prone to be around those 2 things. So compounding always gives you a lurking variable. There's the lurking variable. So the act of having something that makes both of them go up, that's compounding. What makes them compounding is the lurking variable. And that's kind of a neat little thing to know. Observational studies do not allow a researcher to claim causation. Cause. It only lets you claim association. So if I watch a person sleep and I watch them for 2 weeks and they're just all screwed up, I can't come to a cause. I can just say, your sleep pattern is screwed up. You see what I'm saying? I can't say your sleep pattern is screwed up because you have, overcompensation issues, or your father beats you, or, I can't do that just for an observation. Compounding variable, so I don't test you on that one. It's an explanatory variable that was considered in a study. Whose effect cannot be distinguished. Okay, that's the difference between a lurking variable. A lurking variable can be distinguished. A confounding cannot be distinguished. So confounding cannot be distinguished. All right, I want you to write down cross-sectional study and case control study. Not case control. Cross-sectional and retrospective. Okay, they changed the name. It used to be called retrospective. Now it's called case control. 2 semesters ago, it was called retrospective. So I guess it wasn't sophisticated enough. Cross-sectional studies is the observational studies about individuals at a specific point in time over a short period of time. Like in the last 6 months. Okay, in the last 6 months, we have seen a decrease in blah, 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 blah. That's cross-sectional. And we predict in the next 6 months, it's going to be this, this, and this. That's a cross-sectional study. Or you look at the data in the last 6 months or the last 3 months. Versus retrospective, which, like I say, in the last 24 years, that's what it's been called. This is the first book I've ever seen call it case control studies. That's where you go back in time and study things like in the 60s and 70s and predict something in the 2020s. And you pull the last 50 years of data. That's retrospective. And that would be a standardized test question, those two. Now, I'm going to tell you to write a census down because everybody in the world should know, everybody in this room should know what a census is, but it's going to take it every 10 years, and it's basically probability and statistics for the nation. More statistics than probability. CENSUS. I don't know why it's called a census, because centus is every 100 years. Or century, centus, cent, those all represent 100. So I always wondered why they call it a census when it only represents every 10 years. I don't know, maybe I have to study my Greek a little bit more. Or Latin, whatever. Heaven forbid we actually do statistics on our nation. Shut up, Hubert. All right, that's 1.2, and that's under the wraps. Now, 1.3 and 1.4 is just one section. I don't know why they divided it up into two sections, but it's only one section. And that is what types of, let's see, what types of studies are convenient sample? What kind of sampling? Yeah. Now, I'm not going to tell you this big, long definition of random and simple random. I'm just going to tell you what a random sample is. A random sample, dash, everyone has the same chance. Write that down. Everyone has the same chance. A random sample in this classroom, let's say that I took each of your names and I wrote it on a pink Post-it note, and I folded that Post-it note in half, and I put all the Post-it notes in a fishbowl or bowl or hat, whatever you want to call it. Is that a random sample? Yes. Why? 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 Because everybody has the same what? Chance. And the words, everybody has the same chance, that or everything has the same chance, whatever you're dealing with, that is the key to a random sample. Everyone has the same chance. What's the difference in a random and a simple random? It's just, let's say that I put these 4 people on a Post-it note, and I call that group A. And I put those 3 people, call that group B. It's group C, group D, group E. And instead of putting 15 pieces of paper in a bowl, I only put 5. Group A, group B, group C, group D, and group E. And therefore, everybody has the same chance. That's called a simple random sample. So make sure you know the difference between those two. The third best sample to do is called a systematic random sample. Systematic random sample should be on the next page. Somewhere on the next page. Oh my gosh, really? We don't even do anything with a random sample. I mean, why are they doing all this stuff? That's 1.3. 1.4, this is ridiculous. This is a waste of paper. 1.4, if I ever get there, that was 1.4. Did I skip 1.4? There. And they start with stratified, which is the second to last. Don't write that down. I'm putting it in order by there. A systematic random sample. Let's say that I don't have but 5 Post-it notes, and I can't use groups. So I go through and I pick every third person. 1, 2, 3, I put your name. 1, 2, 3, I put your name. 1, 2, 3, I put your name. 1, 2, 3, I put your name, and 1, 2, 3, I put your name. That's a systematic random sample. Why is a systematic random sample important? Because it saves time, and if you save time, you're saving what? Money. Systematic random sample is the third best. A lot of people say it's second best to random sample, because some people don't want to fool with a simple random sample because you have to deal with groups. So a lot of people would say a systematic random sample is second to random sample as far as a good sample. Now, what's the third best? The third best is cluster. By selecting all individuals within a randomly selected collection or group of individuals. let's say that I go down the block and I ask everybody on the block, you know, what's their favorite TV show? That would be a cluster sample. Everybody on the block. In other words, you got 8 houses on the block, that's 8 families. I would ask everybody in those families, what's the best TV show, or what's your favorite TV show? That would be a cluster sample. You could go to a voting precinct and stand outside a voting precinct and ask them what's their favorite color. And that would be a cluster sample because you're going to a group that's already there. You're going to a group that all you have to do is ask them a question. They're already there. That's a cluster sample. Now, a lot of people put that third or fourth because, like I say, you go to a voting precinct, and what are they called? They're called exit what? Exit polls. And the exit polls actually tell if a certain person is going to win that precinct before the votes are counted. Okay? The next is a stratified. Why did they put stratified first? I have no earthly idea why they put stratified first. This is the first book I've ever seen that puts stratified before systematic or before cluster. So I don't know. Maybe the author likes stratified. I don't know. But I've never seen a book put stratified before the others. I'm trying to get there. There it is. Stratified is when you go inside the cluster and break it up into male and female, or break it up into 18 and below, or 18 and above, and 25 and above, or break it up into Democrat and Republican and Independent and Libertarian. I personally wish we had 5 or 6 parties. I think the more parties you have, the better. Now, are these test questions more standardized than Hubert questions? Because I stay away from, I mean, I may ask you, you know, the random sample, and I might ask you the systematic random sample. But usually, I don't usually put these on the test, but standardized tests, they do. And then the last one is called a convenience sample. And I'll be honest with you, they could have done all this on like 3 pages of book pages. They could have done this in 3 pages. I'm trying to find it. If somebody could tell me what page it's on. I think I done passed it. It must be on that previous page. 1, 2. There. A convenience sample would be me asking y'all, do y'all want to improve yourself? Why? Because you're in what?
You have a work email.
What are you doing already? You're improving yourself. So why is that a convenience sample? Because I'm asking you something I already what? Know. Another thing would be, you know, hollering out your apartment window and asking somebody, hey, do you like to stay fit? And they're walking down the sidewalk. Well, if they're walking down the sidewalk, they're walking for one of 2 reasons. What are the 2 reasons? They don't have a car, transportation, or they're trying to what? Stay healthy. So that's a convenience sample. Convenience samples are usually the least what? Reliable. I don't know if the book tells you that, but it is. You look like you're in deep thought. All right, convenience sample. And that is 1.3 and 1.4. So 1.3 and 1.4 basically goes over 1, 2, 3, 4, 5, 6 words. .5 is very important because if you don't understand 1.5, when you get to your master's degree and doctorate degree and you do research and stuff like that, you got to know about this guy. What word is that? Bias. You'd be surprised on the society that we live in. We get people mad at me for bringing up a word that's in their book. Don't ask me. I actually had a complaint last semester about talking about bias. I don't know why, and my department head couldn't understand why, but the person complained that they didn't feel it was necessary to talk about bias in statistics. Anyway, it's only in every statistics book, that's all. I ain't kidding you. We got some kooks out there, I ain't kidding you. If the result is not representative of the math, okay, if you turn the math to your personal feelings. Mark Twain had a famous saying about statistics. Anybody know it? No. Write it down. There's lies, damn lies, and statistics. Write it down. You might need to know that someday. You might be on dadgum Jeopardy one day if they ever start playing it again, and they may ask you that question. Why? What did he mean about that? He meant that there are people that lie, and then there are people that lies a lot, and then there's people that do statistics. And they are what? Biased. Can you think of any profession that is not biased? I can. I can think of 2. Can y'all? A judge. And what's the other one? An umpire or a referee. Now, unless you're a Clemson fan, which if anything goes wrong with Clemson, what do they blame? Besides the seats and the field and the stadium and the referees, okay? They blame everybody, including the Russians, all right? And I've got 2 degrees from Clemson. Gave them a lot of money, but they are the spoiledest fans that there are. Anything goes wrong, it's everybody else's fault. I can't stand to watch Clemson football because of the fans. Anyway, what? I can't stand to watch it, period. And it's not because of the team. I love my school and I love the team, but I can't stand the Clemson fans. They're crazy.
What was the rest of the Mark Twain quote?
There's lies, damn lies, and statistics. Now, you got bias in the questions. You can have bias in the interpretation. You can have bias in the calculations. You can have bias in the presentation. There's all kinds of things that you can be biased about. Now what keeps you as a person? How do you know if something is biased? Well, you got to educate yourself. The more education you have, the more you know that something is biased by looking at some certain things. For instance, if I give you a poll and I say that 75% of America, I went across America, I went from coast to coast, and 75% of America says this person should do this. And I went from South Carolina to Georgia, to Alabama, Mississippi, to New Orleans, to Texas, to Arizona, to Nevada, and Southern California. Did I go from coast to coast? Yes. But what did I neglect to tell you? I covered the South. Does that mean anything? Yes. People from the South think different from people from the North or the Northeast or the Northwest. Okay? So you're going to have a little bit of difference. Just like if I was to ask, you know, if I was to ask 75 independents and 25 libertarians, that's 100, right? If I was asking them who's going to be the next whatever, well, that's not right. Why? Because I'm asking 75% independents and 25% libertarians. Is that fair? No. So how do you know when something is biased? You've got to dig. You've got to research. Okay? Can I ask a biased question? Yes. And they show you some examples. So when you fuss about bias to my department head, make sure you reference the book, okay? Because you need to fuss at them too. Under coverage. I really don't want this to come out a different way. So instead of asking 1,000 people, I'm only going to ask 10, and I'm going to ask 10 people that I know. Is that bias? Yes. That's under coverage. And they give you some examples. Non-response. There are some people that when you don't respond to a survey, they count you for being against something or for something. You can't do that. You have to have another column that says did not respond. You ever seen a graph on TV or in a magazine that has 75% of the people and 20% of the people? And then they don't show anything else. 75 and 20 is what? 95. What do the other 5% say? Response bias. When the answers on a survey do not reflect the true feelings of the respondent. I love to do those polls on, I love for them to call my house and do polls on the phone. I love it. I just can't wait for them to call. Yeah, because I ask them questions. How many people are y'all asking for this poll? And that second question you asked, that was kind of a leading question, wasn't it? Oh, I give them fits. Okay? Because when I went for my master's, I had to go through a whole semester, 4 classes of bias. Well, it wasn't bias, but it was teaching you how not to be biased when you do a survey, when you do a question. Those are 4 classes. One class was on questions, 1 class was on the survey, 1 class was on tallying, and 1 class was on interpretation. And that's what you have to do when you do your master's or your doctorate or whatever. So here's an example. Okay, there we go. Do you oppose the reduction of estate taxes, or do you favor or oppose the reduction of estate tax? Which one's better? Second one. Okay. The first one, you might as well say, don't you oppose the next tax? I mean, you might as well just go ahead and just answer the question for the person, because that's a leading question. All right? It's kind of like when you walk up to somebody and you don't believe in the tooth fairy, do you? I mean, when you walk up to somebody and say, you don't believe in this, do you? Well, that's a leading question. You can't do that when you're dealing with statistics. You can't. You have to be right down the middle, even though you don't like it. I sit on the land use board, okay? I've been on the land use board for 1,000 years, okay? And one of the things about the land use board is, I'll tell you a certain thing. We had a guy come up to the land use board, and he wanted to put a mobile home on 0.68 acres. Everybody with me? 0.68 acres is a little less than 3/4 of an acre. Everybody with me? And the whole community came in there and they were against it. Oh, he's gonna put a strip club up. He's gonna put this up. He's gonna do this. He's gonna do that. He's gonna do this. No, he wasn't gonna put a trailer on it. He was gonna build a house on it. And they said he was gonna put a trailer on it. They said a trailer, not a mobile home, a trailer. Okay? And I lived in a trailer for 12 years, so it don't matter to me whether you call it a trailer or a mobile home. Anyway, to make a long story short, the problem was to have a septic tank, you have to have 3/4 of an acre. Everybody with me? And you can't put a building on a, so I finally did my talk, because I was chairman, and I said, first of all, I'd like to tell everybody in here that I don't care what he puts on the property. That's not what I'm trying to decide. What I'm trying to decide is if we're setting precedent for everybody in Anderson County to put a septic tank on less than 3/4 of an acre. So we turned it down. Why? Because then somebody else could come in behind that and say, look, I got half an acre and I want to put a septic tank on. You gave this guy, you let him do it. Well, unless there's a medical emergency, he can't, there's some kind of medical emergency or something like that, we don't, okay. The whole point is, I had no druthers what he put on that property whatsoever, but I had to rule against it because I didn't want to set precedent. That is neutrality. That is non-bias. Is that hard to do? Yes. It's very difficult. So you have to know what bias is. Do you think the United States should forbid public speeches against democracy? Or do you think the United States should allow public speeches against democracy? Which one's better? B. Okay. Shut up, Hubert. Keep going. Shut up. Keep going. Okay. Sometimes I have to make myself shut up. Next. Type of question. Make sure you know what an open question is. An open question is one that leaves a chance to answer. You have 3 or 4 lines that you can fill in an answer. Do you stay away from open questions in a survey? Yes. Because how do you find the average of your essay questions? You can't. But you can find the average of a closed question, but you have 5 choices. 20% said drugs, 30% said violence, 50% said single-parent homes, and so on. So you always stay with the closed type questions. Now, just like your evaluations for your classrooms, for your classes, they do let you have 3 or 4 open questions at the end of your evaluation. And that's good because the teacher likes to read those. I do. Okay? Question, gripe, complaint. And like I say, I'm just hitting the highlights. I'm not going to worry about that because we don't get into errors in here. I'm not going to worry about that. And that's 1.5. So chapter 1 is under the belt. And now you have, and you can go in and count how many words you got in there basically. How many words you got, like definitions. Give me a round number, 20, 30. Don't count the nominal and ordinal. I don't test you on that. About 30. So there's about 20 questions I can pull from in chapter 1, and you're probably talking about 2 or 3 questions. I think there's 4 questions on the test from chapter 1, and I can tell you what they have to do with qualitative, quantitative, discrete, and continuous. I know those 2 questions are on there. One is which is continuous and which is discrete and the continuous, and it gives you an example. And the other one is Qualitative and quantitative. Which one is it? And I know there's 2 questions from chapter 1. I can't think of anything right off, but we'll look at the test whenever we get to the end of unit 1 and look and see what type of questions. Chapter 2. Say again? You don't have to ask, you just go. Don't worry about it, you're conditioned. It'd take you a semester or 2 to, get out of the conditioning. There we go. Frequency distribution. That's a 25-cent word for a table or chart. Why do I say it like that? Because I firmly believe that whoever invented statistics and probability couldn't make it as a mathematician. So what they did is they decided to make a branch of math that sounded sophisticated. So they made up all these big ass words to sound like they knew what they were talking about. One is frequency distribution. A frequency distribution is a chart or a table with a category or class on the left and a head count on the right. Blondes, brunettes, redheads. 5, 4, 3. That is a frequency distribution. Now there's 2 types of frequency distribution. A qualitative type, blondes, brunettes, and redheads, and a quantitative type, ages. Ages in the classroom. That would be quantitative. A qualitative frequency distribution has categories on the left. A quantitative has classes on the left. And we'll see that in just a second with the examples. Oh, this stuff's rough. Here is a qualitative. How do you know it's qualitative? Because they ain't got no numbers. There's no classes here. These are nothing but categories. Back, wrist, elbow, hip, shoulder, knee, hand, groin, neck. Somebody give me the average. You can't, because it's not numbers, it's categories. This is a qualitative frequency distribution. Now remember, to find the total, all you do is add up all the numbers, all the head count. Just like if I had blondes, brunettes, and redheads in here, I would add up the blondes, brunettes, and redheads, and that should equal how many people are in the classroom. Same thing over there. You add up 12 plus 2 plus 1, all the way down to 1, and that's called N. N is always your biggest number. N is always your total. So that's a good definition right there. That's a good example of a qualitative frequency distribution. Also known as a what? A table. Wait till we get the histogram and bar chart. Shut up, you. Kind of like the person that says they're an engineer and they never went to college. Yeah, you're an engineer. I used to know a guy that used to say he was an engineer. Never set foot on a college campus, but he was an engineer. It's like saying you're a psychologist and you've never taken a psychology class. Whatever. Relative frequency. Can anybody tell me what relative frequency is? Anybody want to give that a shot? It's a percentage. Relative frequency is your percentage. I didn't tell you you could leave. So relative frequency, just mark that out and put percentage. Or decimal, because you got to multiply the decimal times 100 to get the percentage. And I'm not going to insult your intelligence. I'm just going to show you the example down here, and there it is. Where did they get the 30 from? Well, that's the total. And then you put 30 under each one of your numbers. 12 over 30, that's 40%. 7%, 3%, 7%, 1.3%, or 13%, sorry, 16%, or 17%, 7%, 3%, 3%. That's relative frequency. Y'all start to see what I'm talking about. A table is called a frequency distribution, and a percent is called relative frequency. Bar graphs. I'm going to go ahead and tell you the difference between a bar graph and a histogram. There's a bar graph. Does anybody know the difference between a bar graph and a histogram? That's a Pareto chart.
I thought it's like a bar graph and then they don't touch the histogram.
That is the difference between a bar graph and a histogram. I'm sorry, but that's just a joke. I'm sorry. Why do you have to learn two definitions when they're the same dang thing? So if you want a histogram, you take all those blue boxes and you smush them side by side, and now you got a histogram. The histogram was brought on by statistics. So there you put histogram in there with relative frequency and frequency distribution. And hold your pinky up when you say it. I'll show you how to do a bar chart and all that. When we get to the Excel in Chapter 3, I'll show you how to do that. There's your definition right there that you were talking about, a Pareto chart. A Pareto chart takes your values and puts them in descending order. So those same values that you had right here, see the purple ones? That's what they look like in descending order. Now, why do you need to know Pareto chart in my class? You don't. You need it for standardized tests because they will put that on a test and they'll say, is this a bar chart, a histogram, or a Pareto chart? And they'll have the numbers 15, 10, 12, or 15, 12, 10, 8, 6, 4, 2. That's a Pareto chart. Technically, a Pareto chart is a bar chart, but we won't go there. Just like a rectangle is quadrilateral, just like a square is quadrilateral. But we won't go there. Side by side. I see everybody's still writing, so I'll give everybody another couple of seconds. Okay? Side-by-side charts. Now, I'm going to tell you a story before I tell you a side-by-side chart. There's a side-by-side chart. It's when you have, like, retrospective, 1990 versus today. That's when you do a side-by-side chart. But do you need to get into side-by-side charts? Well, when I first started at Tri-County Tech, they put me in a position, it was part-time, but basically I was crunching numbers and doing presentations for somebody that was non-mathematical. Does that make sense? I was an actuator. I basically just put numbers together and I did PowerPoints. And I took my first presentation to my supervisor, and she was my counselor at Tri-County when I was a student. And now I was working under her as a math person. And she looked at it, it was like 10 or 15 pages long, and she said, no, it won't do. She said, we need to have a talk. when you present material to administrators, keep it below a 6th grade level. I was like, these are educated people. This is academia. You want me to put it at 6th grade level? And she explained. Does anybody want to know why you keep it at a 6th grade level? Anybody? Same thing as KISS method. What's the KISS method? That's what it sounds like with the mask on. What does the KISS method stand for?
Keep it simple.
Keep it simple. Your parents did good, whoever said that. Keep it simple. 6th grade or below, it keeps everything, keeps the presentation simple. When you start getting into stuff like this, you start getting away from that. So when do you need to use these? Very sparingly, okay? You use these fancy charts very sparingly. If you do a presentation, you put a bunch of fancy charts in there, you're going to lose your audience, unless they're all mathematicians. Or, I'm sorry, statisticians. That's the new profession that came out of it. Statistician. I'm a statistician. Statistician might as well hang a sign around. Shut up, Hubert. Shut up. Horizontal bars. Is this necessary? No, this is more of a personal preference. Okay? Some people like horizontal bars. I think in this case it looks better because you're not reading up the side of the, you're not reading up the y-axis. So yes, it does have an advantage. And in this case, this one looks a whole lot better. Remember, when you do a horizontal, what does the x and y-axis do? It switches, flips. So remember that. Question, gripe, complaint. I'm going to try to get to the end of 2.1, okay? What is the most applicable chart? The pie chart. Make sure you make a note of that. You will be tested on pie chart and a bar chart, but I can guarantee you will have a pie chart on a standardized test or my test. Make sure you know how to read one. So if I give you 100 people, how many of them have a bachelor's degree? That would be, is that 20 or 26? I can't see it. 20. At a 15-degree angle, I can't see. 20, so 20 people would have a bachelor's degree. Make sure whatever number they give you, you know to multiply by 0.2, by 0.12, by 0.12, by 0.3. So they give you 5,420, you'd multiply 5,420 times 0.2, and that would be, and most of you know how to do that because you've had at least Algebra 1 to get into this class. So somewhere you should have come across a pie chart. Okay, make sure you know how to read it. Capiche?
So are pie charts like the most accurate?
They're the most used because it's easy for people to see it. Your chart is only as accurate as your math. So if your math is accurate, the chart, whichever one you're going to use, is going to be accurate. The most well-liked or the most popular is the pie chart. And that's 2.1, and I'm going to shut her down right there.
Wait, you said they multiply by 0.2?
Yeah, you always multiply by the point. So if you got percentages, you got 12%, you multiply by 0.12. If you got 20%, you multiply by 0.2. If you got 30%, you multiply by 0.3. You move the decimal 2 places to the left. Okay? We'll get to that. All right, now, right quick, I'm going to call the roll and shut down the recording.